And the decimal terminates, I suppose. So those are two different ways to kind of represent why that is a rational number. The decimal terminates, 1.21, it stops, rational. And because the decimal stops, we can write it as a fraction. So you can use either sort of definition to kind of help you out here with the y, which kind of can get a bit tricky sometimes. So just a couple examples, kind of get you guys a little bit more comfortable. Today, we're going to talk about the real numbers now, and we always use this little picture to represent them. And I guess we need to fill this out. So if we take a little step back in time, like go back 1,000 years, maybe 2,000 years, you think about how people represented numbers. When people started thinking about numbers and how numbers sort of worked, what did they use numbers for? Well, mainly they used numbers to count things. If I was a sheep herder, I had a flock of sheep, I would count the sheep and say I had 22 sheep. That was my flock. So you would count. And if you had loaves of bread, how many loaves of bread? You'd count. So any sort of counting number we call a natural number. So this is the most basic form of numbers. Jade asked a question about the caret. If you have the caret button, that's good. I have a feeling you probably, unless you have a TI-83 like my big fancy one here, you probably have an X to the Y button or an X square root button somewhere on there. I don't want to talk about that quite yet because we're going to spend a little bit of time. I guess I could. So if you only have the caret, I'll just write this kind of as an aside on my page here. You don't need to write this down. I'll just throw it in this little circle here. So if you have the caret and you want to use a cube root of the caret, please don't write this down unless you have only the little hat button. So you probably need to go, so let's go negative 27, so plug that in, and then you press the little hat. And then if you want the cube root, you have to put it in as 1 divided by 3. So that should give you negative 3 as an answer. So if you wanted to do the square root with the little hat, you could go 4 caret 2, which should give you 2. Or you could think about like 9 hat 2, which should give you 3. So TI-30XA, that's above my 0. Every calculator is different. That's why this gets really tricky when we're not in the same room, because if we were all together, I could say, oh, just press this, you're on your way. But we're not quite there. So if you have to resort to the hat or the caret, and you maybe have another button, you can always test it. Just put in this something you know, and just test it that way, and see if you end up with the answer you expect. And then once you get it kind of behaving how you'd like it, then you kind of know how to use it. So sorry for that little aside. We're going to go back to this number theory. So if I'm counting, I have all of these numbers counting 1, 2, 3, 4, 5, counting things. These are what we call natural numbers. And these are what we have in the middle, natural numbers of our sort of real number system. Now, for a long time, it seems really strange, but for a long time, nobody had anything that represented 0. If I was just counting things, if I didn't have anything, why do I need to represent nothing with a number? So it literally wasn't for thousands of years of counting things until a few civilizations came up with the idea of 0 being representative of there being nothing. So this kind of came into the next type of number that we talk about is whole numbers. So whole numbers include 0. And I'm just going to put on the outside of this whole little picture here, natural numbers exclude 0. So we have a whole nother type of numbers that has 0. And if you see the image is a bunch of circles that kind of include one another. So if you think about my natural numbers, 1, 2, 3, 4, 5, they go on forever as far as I want to count. So those are my natural numbers. And then if I include 0, 1, 2, 3, 4, 5, those are my whole numbers. So all of the natural numbers are included in the whole numbers. So we have the natural numbers and then the bigger circle is whole numbers because we have that 0 in there now. So the only difference between natural numbers and whole numbers is that natural numbers don't have 0 and whole numbers do have 0. So it kind of seems silly to include a whole other number type just for 0, but we do, whole numbers. Then we get a little bit bigger. So we can have things like integers. You guys have probably heard the word integers before. And integers are whole numbers, but what makes integers special is that we can have whole numbers and then we can have negative whole numbers. So once we include negative numbers, then we have something called integers. So again, starting at the inside, the smallest circle, we have our natural numbers. So that's 1, 2, 3, 4, 5, going on forever, just counting. And then if we include 0 in there, then we have our whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, those are whole numbers. And then if we think about 0 and go in the other way, if we include negative numbers, we have our integers. So negative 5, negative 6, negative 7, or I can go the other way, 5, 6, 7. I can count on in either direction on a number line forever, as long as I'm hitting whole values, so no decimals yet. Those are what I would call integers. And you guys have heard the word integer before, I'm sure. The next step in our little circle of fun here is rational numbers. And we know these rational numbers can be decimals. As long as we can represent the decimal as a fraction, we can call it a rational number. So if you think about kind of the progression here is we have numbers with no decimals, we have positive and negative numbers, and then once we've run out of positive and negative numbers, we have all those little spaces between the whole numbers to fill in with decimals. And that's what we call our rational numbers. And then outside of all of our circles, things that can't be written as a fraction are our irrational numbers. So we have irrational numbers gets its own little circle outside of all of our circles. So these are things that make up the real number system. So we have rational numbers, integers, whole numbers, natural numbers. Now, I wonder if I probably don't have enough room, but I'll try. Let's maybe just throw a couple examples in here. So natural numbers are like 2, 3, 4. Whole numbers are 0, 1, 2, 3, 4. That continues on forever. Integers would be things like negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And then anything that doesn't fit in there, we have like 0.23, 1.75, negative 8.543. Those all work. And then irrational numbers, these are going to be things like square root of 2, or pi, or 1.754392, continuing on forever. So Alex, you're asking a question about the learning guide. I'll get to the learning guide in just a second. I'm just going to do the number line question, and I'll go back to that, Alex. So hopefully you can just hang with me for a second. I will not forget about you, I promise. So the last example we're going to do today is using a number line. Order these numbers from least to greatest. So if you think about what we're dealing with here, square root of 2 is going to be about 1.4. Cube root of negative 2, not sure what that is off the top of my head, but it's going to be a smaller number. Cube root of 6, square root of 11, and the fourth root of 30. So first thing I'm going to want to do is figure out the decimal values for all these, because if I have to put it on a number line, I need to kind of see what I'm dealing with. So just down below, square root of 2 is 1 point. Let's get the exact value here. Square root 2, 1.4142. If I take the cube root of negative 2, what do I get? So on my calculator, I'm going to go 3, second function, x, and then negative 2, so 1.2, negative, sorry, 1.2599. Cube root of 6, I don't know what that is either, so figure what that is. I end up with 1.8171. Square root of 11. 3.3. And the last one is the fourth root of 30. 2.34. All right, so those are all my, is there a fourth root button on a calculator? That's a good question. No, generally calculators will probably only do like the third root of something. So probably you're gonna have to find the x with the root and the y underneath, or the y and the root and the x underneath. Like I was saying before, unless you send me a picture of your calculator, I'm probably not going to be able to help you until you do that, and then hopefully I can figure it out then. So just going back to the questions here, I have a negative value here, just the one negative. Yep, I have negative value. So the smallest number I'm going to have is negative 1.2. The largest I have is the 3.3. So I need my number line to kind of accommodate numbers from about negative 1 up to about 4. So if I take my number line and I go with negative 1, maybe go by 0.5, negative 0.5, 0.5, 1, 1.5, 2. Everything kind of fits there now. Now it's just a matter of figuring out where these things kind of go. So the first one here I have is 2, the root of 2, which is 1.4. So that's going to be just before 1.5. I'm going to put square root of 2 right there on my number line. So Taylor's asking a question about the fourth root button on our calculator. So Taylor, you're probably going to press the 4 and then the x square root y button, and then the, what were we taking the fourth root of? And then the 30. So probably 4 x to the y, or square root xy, and then 30, and then hit equals. That should get you where you need to be. All right, so we have root 2 on there. And then the next one is the cube root of negative 2, which I know is negative 1.2. So that's going to be way over here. There's negative 1. So this is the cube root of negative 2, way over there. The next one is the cube root of 6, which was 1.8. So that's going to be just before 2. And then I have square root of 11, which was 3.3. And then the last thing I had was the 4th root of 30, which is 2.34. All right, so the idea here is that I put all these numbers in red down below. Those are all my approximations for these, because these are all examples of irrational numbers. So I've found an approximation for them in red at the bottom, and then I figured where those numbers would fall on the number line. Now, I didn't put the decimal representations on the number line. I put the exact values, so like the square root of 2 and the 3rd root of 6. So those are the exact values, but just kind of approximating where they fall on that number line is kind of what I did there. So that's kind of an introduction to these numbers, number theory, irrational, rational. There's kind of a lot of words I said that you've probably heard before that maybe hadn't really registered in your brain, but now we're going to have to start thinking kind of in terms of what these numbers mean. So Alex asked a question about the learning guide before, and I want to just mention a few things about it. So as I said at the beginning of the class, instead of doing the practice questions for each section, we're just going to go through some of the learning guide questions in terms of practice. So what did we do today? At the very beginning, it says, use pencil, complete the following work. So I'm going to throw a little red star next to the stuff that you should complete for next day. So number system stuff, we did, for sure, all of that. You should be able to do the number lines as well. And we're going to move on to estimating radicals next day. So the first 2 pages, I would like you guys to have a look at for homework. Now I realize a few of you have left some of the Unit 2 stuff a little long, so you're going to have to go through that stuff, and then you're going to have to figure this stuff out. So that's kind of why I was kind of giving you these deadlines for the quizzes, hoping to keep you on track. Alex had a question about the other 2. So we had, what did we have? Natural for F, E is whole, integers. Alex, the only one we should be missing is A, and I'll give you guys that one. It's the real numbers. So everything together is the real numbers. And then we have rational, integers, whole numbers, natural numbers. So that would be the only one I didn't talk about. Everything else is on the image there. So hopefully that helps you out a little bit, Alex. It's really important that you guys finish off Unit 2 essentially today. You need to get that test written in the next day. You need to get those 2 quizzes done. You need to get your learning guide in. Because we have to keep moving, and it's important that if you're still working on Unit 2 and now we're in Unit 1, now instead of doing the practice for Unit 1, you're probably going to be finishing off Unit 2, and now you're doing 2 units at the same time, and it's just a bit of a mess. So I don't want you guys to fall behind. I don't want you to be worrying about Unit 2 stuff anymore, because we need to be worrying about Unit 1 stuff now. Unit 1 has 5 lessons. The last one I'm going to do is 1, so we should be done Unit 1 on Monday's class, which means that you guys will have another unit test, which will be 20 questions again, but it's on less sort of material. That means that'll probably have to be done by next Wednesday as well. So we're looking at another test coming up right away. I think there's only 2 quizzes in Unit 1, maybe 3. So it's definitely not as long of a unit, it's not as hard, just a little bit of stuff to memorize. And that's kind of where we're at in terms of the course. So please, please, please get Unit 2 wrapped up, whatever you need to do to finish Unit 2 today. Has to be done today because we're moving on. Are they going to be timed? I just kind of forget sometimes that these quizzes are timed. I forget to turn it off. So if I ever leave it on and you're like, it's timed, you run out of time or something, just say, hey, Mr. Borden, you forgot to turn off the timer. Then there you go. So yeah, Abby, yours wasn't. They shouldn't be timed. It's just the default of all the quizzes and tests is to time them, and I try to remember to go in and shut the timer off, but sometimes I just forget. So if you ever have an issue with that, let me know and I'll go and shut it off. It doesn't really matter. Take as much time as you need. Taylor, the code for the test, once you've submitted the review and everything looks good, I will send you the code for the test. That's kind of the first step, is getting your review in. I have class all morning, so I won't be able to look at your reviews for a little bit. Your learning guide wouldn't work to send you. Okay, we'll figure something out. Jade, maybe try to email it directly to me instead of submitting it through the course or something like that. I'm kind of running a minute long here, so I'm going to leave you guys for now. If you have any questions, send me a message in Moodle, and I'll get back to you as soon as I can. But if not, hopefully you can get done Unit 2. And we'll see you guys when we see you tomorrow. I believe you guys have English coming up here in about 5 minutes or so, or maybe planning. I'm not sure. Taylor, I will get it to you as soon as I can, but I do have class this morning, so. And you can get me your stuff when you get me your stuff. That's it for now. And thank you, Abby. You guys have English, so you guys get signed into there. Take about 5 minutes or so. I'll let Mrs. Ward know that I went a little long, and she'll wait for you guys. Thanks. We'll talk to you soon. Bye.